let me walk you through a couple of these problems here, okay? Um, I'm not even going to bother going through the first couple. They should be pretty elementary, okay? Uh, and I did try to address some of these with, you know, other videos. Now, number 5 is not so bad, so all you got to do is square both sides, and then you get c squared plus 6c equals 4c plus 35, and that's pretty elementary from there. You should be able to track the problem. You can't get the impression down here, 6 and 7, that you could just square this, and square this. It doesn't work that way, okay? What we did up in number 6 and number 5 was we squared both sides. We didn't square individual pieces. We squared both sides. So the idea here with problem 6 and problem 7 is that you're going to have to square both sides. But I'm not going to square both sides until I rid myself of the radical of at least one of the radicals from this left side. So I'm going to do it this way and add that 2y plus 10 radical to the other side. Now I'm ready to square both sides. I'm ready to square both sides. Now squaring both sides on this end will give me 4y plus 13. That's nice. Squaring both sides over here is a binomial. A binomial of the form a plus b to quantity squared, which you need to adhere to a squared plus 2ab plus b squared. Otherwise you're committing an atrocity. That being said, this one squared is 1 plus 2 times that radical, so I'm not rid of that radical, plus, okay, that expression with the radical squared, which is just going to give me the 2y plus 10. So as you can see, these two radicals, I wanted to isolate one per side, square both sides, squaring, adhering to the rules of algebra, okay, and not your own rules. Let's tighten this up a little bit. All right. So I've got 2y. I can lose the 2y off of here and drop this down to 2y. I got a 13. I can subtract the 1, that is 11, and then I'm going to subtract. Let's see here. Yeah, we're going to have 10, so that's going to drop that down to plus 2. Check that. Okay. Again, 2y taken over. 1 and 10, 11, take it over here. Okay, now, I've isolated this radical, 2y plus 10. You don't have to divide by the 2. I'd actually suggest you don't. You got to square again. Square again. Square again. Because now it looks like the previous problems, okay? Again, this is a binomial. It squares 4y squared plus, okay, this is going to be 4y doubled, so that's 8y plus 4, and over here we're going to get 4 times 2y plus 10, so it looks like we're going to get 8y plus 40 and equals 4y squared. You should be able to take it home from there. Okay, we're going to lose the 8y's, so what are we looking at? We lose the 8y's. I got 4y squared is equal to 36, it looks like, okay? So it looks like we're going to get what y squared equals 9. So looks like y is going to equal plus or minus 3. And just so you'd be so advised to check that. All these that follow, the 7 is going to be done the same way. I'm not going to do that. So show you how to do it over here. Okay, over here. The square root and the fourth root. All right. You might benefit by looking at my posting that I put up on the exponents, and you should realize that this is a to the 1/2 power, a to the 1/2 power minus minus 3a to the 1/4 power plus 2 equals 0. I'm going to do a little substitution. I'll let u equal a to the 1/4 power. Then u squared would be a to the 1/4 power squared. Multiply inside and outside exponents, that's a to the 1/2 power. So then this comes down to u squared minus 3u plus 2, that's factorable in u. Deal with it, factor it, okay, and then return the u value as the a to the 1/4, okay. I'll just execute the whole thing. That's what, u minus 2, u minus 1, which is to imply that u equals 2, u equals 1. U equaling 2 says that u being a to the 1/4 power equaling 2, so I'm going to raise both to the 4th power here, and that would give me a is equal to 2 to the 4th, which you should know is 16. And I do the same thing with u equaling 1, where again u is a to the 1/4. Raise both to the 4th power, 1 to the 4th, 1 to any power is 1. 16 and 1. Check them both. No guarantee that they're both solutions. Likewise situation here. I'm going to let this 3a to the 1/4 power be u. U is 3a to the 1/4 power. That's this whole thing. So therefore, u squared is 3a to the 1/2 power. Check it. So then that comes down to u squared minus 3u plus 2 equals 0. Looks like the same factors. Same factors as the previous one. Likewise, go to exponent form. 3 equals 3m to the 2/3 power minus 8m to the 1/3 power. Don't like this. Let it equal u. U squared, m to the 2/3 power. There you have it. 3 equals 3u squared minus 8u. Quadratic. Factor, find your answers. Don't forget, once you find your answers in u, come back to replacing u with m to the 1/3, cube both sides, and find your answers. Check your answers. Make sure they're valid when you put them back in. Okay? Negative exponents mean denominator expression. P squared plus 64 over P squared minus 20 equals nothing. Fractional equation. Multiply everybody by P squared. Multiply everybody by P squared, giving you P to the 4th plus 64 minus 20p squared equals 0. Switch it up. Keep the order of the terms consistent. Minus 20p squared plus 64 equals 0. Factors. It's quadratic now. It's what you want it. Okay? Likewise situation here. You have a couple things. You can go 9 over h to the 4th plus 35 over h squared minus 4, multiply by h to the 4th, clear the fraction, goes quadratic. Likewise situation, okay? What do you do down here? Y to the 1/6. Let that equal u. Therefore, u squared is going to be y to the 1/3, okay? So this becomes what? 2u squared minus 5u plus 2 equals 0. Quasi-quadratic. Make it definitively quadratic. Same thing here. Same thing here. Here, what are you going to let u? U equals c plus 1, the whole thing to the 1/3 power. Look at that. Then that becomes u squared minus 2u minus 15 equals 0. Make it quadratic. Quadratics are your friends. Make it quadratic. Do the suitable substitution. Until you do the substitution, it is not quadratic. It's quasi-quadratic. Get it straight, okay? Not difficult problems. Don't make them difficult. Do the substitution. Make them look a little bit more user-friendly. Then deal with it. Always check your answers. Be suspicious of some of those answers. Okay? Get them done.